In the world of manufacturing, we often find ourselves caught in a relentless tug of war between quality and cost. On one side, we have the ever increasing cost of raw materials, labor, and overheads. On the other, the consumer demand for affordable yet high quality products. It's a balancing act, and for many companies, failure to manage these costs effectively can lead to dire consequences: loss of market share, shrinking profit margins, and even the risk of going out of business. So, what's the solution? Enter value analysis. Now, you might be wondering, what exactly is value analysis? Well, it's a systematic approach that helps companies optimize the functionality and features of their products while minimizing costs. Originally developed during World War II to tackle material shortages, value analysis has evolved into a powerful tool across various industries, especially manufacturing. At its core, value analysis dissects a product or a process into its basic functions and evaluates its costs. The ultimate goal: identify opportunities for cost reduction without sacrificing quality. In an era where price wars are the norm and profit margins are razor thin, this method isn't just a strategy, it's a necessity for survival. Imagine this: you're running a manufacturing company that produces high quality widgets. Your competitors are just as good, but they're also slashing prices left and right. If you can find ways to reduce your manufacturing costs through value analysis, you can either pass those savings on to consumers to attract more buyers or maintain your current prices and enjoy higher profit margins. Either way, you're positioning yourself for success. Now, let's break down the key components of value analysis. First, we have functionality. This is all about understanding what your product needs to do. Every product has primary functions, those essential features that allow it to serve its intended purpose. For instance, a bolt's primary function is to hold parts together. Then we have secondary functions, which are those extra features that enhance the product but aren't critical to its basic operation. Once you've identified these functions, the next step is to associate costs with each one. This involves a detailed breakdown of all expenses incurred in producing or executing each function. Think raw materials, labor, overhead, and any other direct or indirect costs. Understanding where your money is going is crucial. Finally, we arrive at evaluation. This is where the magic happens. You'll want to critically examine each function and its associated costs. Ask yourself questions like, is this function necessary? Can it be eliminated, combined, or simplified? Can we achieve the same function at a lower cost without compromising quality? This evaluation process will help you pinpoint areas where you can cut costs or enhance quality. So, how does value analysis play out in the manufacturing world? Let's consider a few key reasons why it's so instrumental. First and foremost, cost optimization. Manufacturing involves numerous processes, materials, and labor inputs. By dissecting these elements, value analysis helps identify cost-saving opportunities that might otherwise go unnoticed. Then there's quality assurance. By honing in on essential functions and eliminating redundancies, value analysis often leads to a more streamlined and effective product. And let's not forget about resource allocation. Knowing the cost and importance of each function allows for better resource management, which is vital in an industry where resource constraints are common. Innovation is another exciting aspect of value analysis. The process can spark creative ideas for product improvements or new production methods, giving companies a competitive edge. And once you successfully implement value analysis for one product or process, the same principles can be applied across different areas of your manufacturing operation, making it a scalable solution. Now, let's talk about why reducing manufacturing costs is so crucial. Manufacturing costs are a significant determinant of a company's profitability. High costs eat into profit margins, leaving little room for error in other areas like marketing and sales. For instance, if you're spending $80 to manufacture a product that sells for $100, your profit margin is a mere 20%. But if you can reduce that manufacturing cost to $60, your profit margin jumps to a whopping 40%. That's a game changer. Moreover, reducing manufacturing costs provides a competitive edge. In markets where products are similar in features and quality, price often becomes the deciding factor for consumers. Companies that can produce quality products at a lower cost can either lower their retail prices or maintain their existing prices with higher profit margins. Let's look at a couple of real-world examples. Take Toyota, for instance. Their adoption of lean manufacturing principles allowed them to eliminate waste in their production processes, significantly reducing costs. This strategy not only led to lower-priced yet high-quality vehicles, but also helped Toyota become a global automotive leader. Then there's Dell, which revolutionized the personal computer market by introducing a direct-to-consumer model. By cutting out the middleman, Dell reduced costs and offered customizable, high-quality computers at competitive prices, securing its position as a dominant player in the PC market. Now, let's dive into the benefits of using value analysis in manufacturing. First, there's cost reduction. This is the most immediate and tangible benefit. By dissecting each product or process into its essential functions and evaluating the associated costs, manufacturers can identify areas where expenses can be minimized. But it's not just about cutting costs. Value analysis also enhances quality. By focusing on primary functions and eliminating or modifying secondary features, manufacturers can produce more streamlined and effective products. For example, a kitchen appliance manufacturer might find that a blender model has multiple speed settings that consumers rarely use. By simplifying the design to include only the most commonly used speeds, they can improve user experience while reducing production complexity and costs. Resource optimization is another vital benefit. Manufacturing involves a complex interplay of various resources, including raw materials, labor, and time. Value analysis helps in the optimal allocation of these resources by identifying which functions are essential and which are not. Now, let's get into the steps for implementing value analysis in a manufacturing setting. First, assemble a cross-functional team. This team should bring together experts from various departments, engineering, finance, operations, to ensure a holistic approach to value analysis. Next, define your objectives. What do you hope to achieve through value analysis? This could be a specific percentage reduction in production costs or improvements in product quality. Identifying key performance indicators will help measure the success of your initiative. Data collection is the next step. Gather information on material costs, labor costs, and overhead. Use cost accounting systems, conduct time studies, and perform material flow analysis to ensure you have all the necessary information. Once you have your data, conduct the analysis. List all functions of the product or process and associate costs with each. Identify areas for improvement or elimination. Develop alternatives by brainstorming methods, materials, or processes to achieve the desired functions at a lower cost. Conduct a cost-benefit analysis to evaluate each alternative based on its potential cost savings and impact on product quality. After that, it's time for implementation. Start with small-scale changes to monitor their impact, and closely track your KPIs to judge the effectiveness of the changes. Finally, remember that value analysis is not a one-time activity. Frequent reviews are essential to ensure that your objectives are being met. Adjustments may be needed based on these reviews, whether it's reverting to previous methods or fine-tuning the changes for better results. Let's look at an example of value analysis in action. Imagine ABC Widget Co., a hypothetical manufacturing company specializing in widgets. Faced with increasing competition and rising production costs, they decide to implement value analysis. First, they assemble a cross-functional team of experts from engineering, finance, and operations. Together, they set a clear objective to reduce the manufacturing cost of widgets by 20% within 6 months without compromising quality. They identify KPIs such as cost per unit and production time to measure success. Next, the team collects data on material, labor, and overhead costs. They find that one of the secondary functions, an anti-corrosion coating, accounts for 15% of the total production cost but isn't a significant selling point for their primary market. During brainstorming session, the team proposes eliminating the anti-corrosion coating for that specific line of widgets and considers switching to a less expensive material that still meets quality standards. After conducting a cost-benefit analysis, they find that these changes could lead to a 23% reduction in cost per unit. They implement these changes on a small scale initially, producing a batch of widgets without the anti-corrosion coating and with the new material. After monitoring the results, they discover that their KPIs show a significant reduction in cost per unit without compromising quality. 3 months later, the team conducts a review and finds that the changes have been successful. They implement the changes across all production lines targeted at their primary market. By successfully implementing value analysis, ABC Widget Co. not only meets its objective but also gains a competitive edge by offering high-quality widgets at a lower price, ultimately increasing market share and customer satisfaction. However, it's essential to be aware of common pitfalls in value analysis. One common mistake is overlooking minor costs that can add up over time. To avoid this, ensure that your cost analysis is comprehensive and conduct regular audits to identify any overlooked expenses. Another pitfall is resistance to change within the organization. To combat this, maintain transparent communication about the reasons for implementing value analysis and involve employees in the process to reduce skepticism. Finally, inadequate data collection can lead to flawed analysis. To avoid this, use multiple data sources and validate your collected data by cross-referencing it with reliable sources. In conclusion, value analysis is a powerful tool that can help manufacturing companies reduce costs and improve quality. By understanding the functionality, cost, and evaluation of each product or process, manufacturers can identify significant opportunities for optimization. In a competitive market, those who can produce high-quality products at lower costs will not only survive but thrive. Embracing value analysis can be a game changer for any manufacturing company looking to gain a competitive edge and ensure long term sustainability.